Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today we are going to discuss a very interesting LeetCode problem, Leetcode61 rotatelist. It's a medium level LeetCode problem, has been an all-time favorite of certain companies such as Amazon, Microsoft, Bloomberg, LinkedIn. They have asked it in their interviews from last 6 to 12 months. What does this question say? The question says that you have been given the head of a linked list and you have to rotate the list to the right by k places. Essentially, you have to make that rotation while maintaining the order. Let us look at an example to understand it better. So this is the linked list given to you 1, 2, 3, 4, 5. 1 is the head of the linked list and you have to rotate it by 2 places. K is equal to 2 here. Okay. So when you have to rotate by 2, essentially what you are doing, you are counting backwards. So this is your 1, 2 and you are breaking here between 3 and 4. And then you are swapping places. So you are bringing 4 and 5 in front here. And then you are bringing 1, 2, 3 here forward. So you are basically breaking here between 3 and 4 after counting backwards for k places. And then you are essentially pointing 3 towards null. That is 3 dot next is null instead of 4. And you are pointing this 5 dot next to the head, to the original head which was 1. And your new head becomes as 4. So I hope the rotation by k places to the right is clear to you. What does it mean? Now, what would be the algorithm to solve this question? So whatever I said is actually the solution. You have to loop along the linked list. You first have to find the total length of the linked list so that you can find the backward k. When you find the length of the linked list, after that you have to find k places from here, from the back. How do you find that k places from the back? To find that pivot point, there's the formula. You can use length minus k minus 1 from the beginning. Because you are starting from the first node and not the 0th node, hence this minus 1 is coming here. So your pivot point would be this, length minus k minus 1. That is, you have to jump these many nodes when starting from the beginning to reach that pivot point. So for example, here your k is 2, so your length is 5. So your pivot point would be 5 minus 2, that is 3, minus 1, that is 2. So when you are starting from the first node, you have to make 2 jumps. So 1 jump, 2 jump, and you reach the pivot point. So 3 is your pivot point. After that, you have to break it, and 3 should point to null, and your 4 and 5 should come to the beginning. Your 4 becomes the new head, and 5 should point to 1, which was your original head. And finally, you return the new head. Now, there could be some exception cases here. Your k could be of length of your entire linked list, or your k could be even more than entire length of linked list. Say suppose your k is 5. That is the length of the linked list. What does it mean by rotating this linked list by 5 places? Essentially, if you have to rotate by 5 places, you are doing nothing, you are returning the same linked list. If you have to rotate it by 6, so if you have to rotate it by 6, by 5 you bring the same linked list. So essentially you are rotating just by 1 place. So to get the right value of k is essentially k modulo whatever the length of your linked list is. Whatever length of the linked list is. So that ways you will get to know exactly how many places you need to rotate right. Okay. So now this is our entire algorithm. It will be done in O n time complexity because you're looping through the entire linked list once without using any additional memory. Your space complexity would be O of 1. Now let's start coding it, okay? First of all, I'll initialize my variables. But before even initializing, I will just check if my linked list is empty. In case my linked list is empty, I just return the linked list as it is, okay? So this is my edge case. Now I get the length of my entire linked list. So to get the length of my entire linked list, I'll compute certain variable length and tail pointer. And I'll initialize length by 1 because I at least know that there is one node in the linked list because it is not null. And I will point the tail to head initially, okay? Now I will run a while loop while tail.next exists. There is a valid tail.next. Until then, keep on incrementing it. So tail is equal to tail.next and keep on incrementing your length. So length would be equal to length plus 1. And this ways you will get your length variable. You will reach the end of the linked list and you will get the tail. Now after that you can get k modulo length because you want the original value of k which is less than the length of linked list and not more than the linked list. Hence we are taking modulo with the length. And we check if the k given to you is equal to actually the length of the linked list. How do you check? When once you have taken the modulo, if this k is equal to 0, that means it is a multiple of the length of the linked list. In that case, you can just return the linked list as it is, because rotating it by its multiple is going to return the same linked list. Otherwise, you move to the pivotal point and you rotate. So I will use a current pointer and point it to head initially and start from the beginning. I have to rotate to find the pivot point. The formula would be length minus k minus 1. So for I in range, length minus k minus 1, and I will rotate. So current will equal to current dot next, and I'll keep on going ahead. Now finally my current will be at my new pivotal point. So I have to save my current dot x here. So I will essentially save for the new head first, because I'm going to change current dot next. So 3 dot next should point to null, right? So current dot next is 3 dot next. So current dot next will be none. My new head is 4, right? Which I have saved here already before changing anything. After that, tail dot next, my tail is 5. And tail dot next will become the original head. So tail dot next will be head, and I would return the new head. My new head would be this current dot next, that was this 4. So what did I do? I saved first 4 here in the variable before I change it. Then I changed 3 dot next to none. I changed 5 dot next to head, which was 1. And then I returned the 4. 4 was saved as a variable new head. That is my entire code. I will run. So it's accepted. Let's submit. This is as efficient as you can get. It is O(n) time complexity because you're entirely looping through the linked list. The space complexity is O1. I can summarize the entire code for you once more. So first of all, we checked if the linked list is empty or not. If the linked list is not empty, then we move ahead. If it is empty, in that case, we just return the head. Now we want to find the length of the linked list. To find the length, we initialize 2 variables, length and tail. Length is initialized at 1 because we know at least one node exists, and tail is initialized at head. Now we'll increment tail.next until tail.next exists, and we'll increment the length as well. That way we will get the new tail and length of the original linked list, okay? Now we have to get k by k modulo length to ensure if k is greater than the length of linked list or equal to length of linked list, we are tackling that situation. So if the modulo comes out to be 0, that means k is a multiple of length of linked list. In that case, we return the linked list as is. Return the head. Otherwise, we move ahead to find the pivot. For finding the pivot, we initialize current pointer with the head. For I in range, length minus k minus 1, that is how many jumps you need to make, how many nodes you need to jump to reach the pivot point. And we do current equal to current.next. That's how we find the pivot point. Now, after finding the pivot point, we save current.next in our new head variable because that would be our new head. And then we change the pointers. So current.next will point to none now. That is, this 3.next will point to none. The tail.next, that is 5.next, will point to original head, which is head 1. And we return the new head, which was 4, which we have saved in this variable. That's the entire code. If you have any questions, ask them in the comments. I'll be happy to address it. If you like my way of solving problems, subscribe to my channel. It keeps me encouraged and motivates me to make new videos. And it will also help you get your daily updates for your daily LeetCode challenge. Thank you.